The influenza virus has been around for thousands of years and spreads worldwide, infecting millions of people and causes thousands of deaths yearly, even more during pandemic years. Although preventive measures are being taken by vaccinating big parts of the population each year, pandemic breakouts still occur. The influenza virus mutates at a high rate, which makes it difficult to find an effective vaccine that would protect from the ever-evolving virus. One way to prevent epidemics could be to stop or slow down transmission of influenza. To be able to prevent influenza from spreading, an extensive understanding for how the virus transmits is necessary. The focus of this video will be on the transmission of the virus and how it can be prevented here at Washington State University, mainly in the Compton Union Building. Influenza transmission can occur via different routes: direct contact, indirect contact, droplet transmission, or airborne transmission. Direct contact transmission occurs when influenza microorganisms are transmitted from an infected individual to a susceptible host via direct physical contact. Direct physical contact, such as a handshake, hug, kiss, or other intimate physical contact between an infected individual and a susceptible host, can contribute to influenza transmission. Indirect contact transmission occurs when microorganisms are transferred to a susceptible host via an intermediate contaminated object, such as a door, handle, or a contaminated hand of a non-infected individual. Droplet transmission occurs when particles bigger than 5 micrometers in diameter. How long droplet and aerosol particles remain active and infectious depends on the environmental factors such as temperature, relative humidity, and exposure to UV radiation. Optimal influenza virus stability and transmission is achieved at low outside temperatures and low relative humidity. Therefore, influenza spreads easier during winter in the temperature regions where the air is dry. At higher relative humidity, virus particles increase in weight due to taking on water. The heavier particles settle much faster than the lighter particles. They do not remain airborne long enough to get inhaled and to contribute to influenza transmission. No transmission occurs at temperatures higher than 30 degrees Celsius. UV radiation may increase the inactivation rate of influenza virus. Therefore, using UV radiation light inside could aid in preventing influenza transmission. Other contributing factors in influenza transmission are called fomites. Fomites are contaminated objects involved in indirect contact transmission. Contamination of the fomite can occur through either hand or droplet transmission. Highly touched fomites with large surface areas have the highest transmission potential of all fomites. Small, highly touched fomites, such as doorknobs and handles, compared to those with large surface areas, such as public tables, are cleaner since pathogens are picked up at a higher rate. It is less likely that viruses get picked up as fast on larger surface areas. In order to control influenza transmission via fomites, extensive hand washing and decontamination of fomites using disinfecting solutions is needed. Another way of preventing influenza transmission in both the aerosol and droplet route is to cover coughs and sneezes using the upper arm and not the hand. By doing this, the fomite transmission decreases since the virus particles are removed from the system. If a sneeze or a cough is covered by the hand, the contaminated hand will transfer influenza virus particles to fomites. However, covering a cough or sneeze by the hand is better than not covering it at all, since it allows droplet and aerosol particles to spread freely. Close places where a lot of people pass through daily are optimal for influenza transmission. Ventilation and air conditioning assist the movement of virus particles so they can spread further. Another factor that can make the potential host more susceptible to influenza virus is stress. Stress reduces the immune system's ability to fight an infection. On the main floor of the Cub at Washington State University, a big portion of the student population passes through daily. Students come to the Cub to eat, study, socialize, take a break from studying or classes, and relax. There are tables and chairs where people can sit and study, TVs and couches where students can sit and watch TV or play video games. There are 2 sitting areas separated by